Today we will discuss the topic subset of a set of a real number. This is a topic. In this topic, there are many important subset of a real. We given below name of the sum of these subset, the set of the natural number. Set of natural number denoted by the letter n. Set of integer denoted by the letter z, and the set of rational number denoted by the z q. We all know about, we can represent a rational number q is equal to p by q, where p and q are integers. Z represent integers, and where there is a one condition, q never be is equal to 0. Now Q is a set of all number x such that x equal to the quotient p by q, where p and q are integers and q is not equal to 0. Because of that, a rational number we can write in the form of p by q and q never be equal to 0. Suppose a number 1 by 2, 3 by 5. So these two are rational number, but if we take 3 by 0, so this is a defined not defined number, so that this is not a rational number. So basically that is the reason behind it, q never equal to 0. Is it clear? And some of the above relation among these subsets are: n mean natural number, n mean natural number, z mean integer, q mean rational number. According to this mathematical representation, natural number is a subset of an integer. Because of that, the set of a natural number is 1, 2, 3, 4, 5, dot dot, and set of integer z is equal to -3, -2, -1, 0, 1, 2, 3, dot dot, and this side also. So natural number are included in the integer. So that's why natural number is a subset of integer, and all integer included in a rational number. So that's why integer is a subset of a rational number. But for this, q mean rational number is a subset of a r mean real number, because real number contain rational and irrational number both. So that's why q is a subset of a real number. So basically these are the example of all these. Here the set of irrational number, t represent for the irrational number. Those numbers which are not rational are called irrational number. So irrational number also a subset of a real number. But natural number cannot a subset of a irrational number. Because of that, suppose that square root 2. So this is a irrational irrational number. And when we solve this one, we will get 1 point something. So we will get decimal number. So that's why this number is not represent the natural number. So that's why natural number is not a subset of a irrational number. Basically, this is a representation for this, and after that, the new topic intervals as a subset of a real number. So let us discuss about the interval. What is the interval? Let A be element A and element B belongs to real number and A is less than B. Then the set of a real number we can represent like that y such that A less than y less than b is called an open interval. This is an important point. This is important for the understanding. Because of that, what do you mean by open interval? Let us discuss. And it is denoted by a comma b in this bracket. So all the points between a and b belong to the open interval like that, but a comma b themselves do not belong to this interval. Suppose a comma b we will take 2 comma 7. So when we represent on the number line these 2 points 0, 1, 2, 3, 4, 5, 6, 7. Here minus 1, minus 2, minus 3, minus 4. So the value, if this interval represent in the small braces, so we can say that this interval include which values? These values. This interval include between these values are these values. It means 3, 4, 5 and 6. Not included value 2 and 7. The between the values, and this we can represent like that: 2 less than x less than 7. This representation basically the for the open open interval, and this sign also used for open interval. This sign also used for the open interval. The sign is less than. So this is the example of the representation of an open interval. The interval which obtained the interval which obtained the end point also is called closed interval and is denoted by this capital braces. This is the representation of a closed interval. For closed interval, we can use these sign less than equal to. This mathematical representation to show for the closed interval. So x such that a less than is equal to x less than is equal to b. Suppose we can also write like that: 2 less than is equal to x less than is equal to 7. So the closed interval shows that the element 2 and 7, and between 2 and 7 all the element will consider this closed interval. Okay, we can represent 2 and 7 also. We can take 2 and 7 with between numbers. It means we can take 2, 3, 4, 5, 6 and 7. All these values we can consider in this closed interval. It means the given value also the part of the closed interval. Whatever given in the place of 2 and 7, we will consider as well 2 and 7 also, and between the values of 2 and 7 will be also the part of this interval. So this basically interval is called a closed interval, and this this is a close and this is a open. This for close and this for open. Okay, so now this is statement x is that x is that a less than is equal to x less than b is an open interval from a to b, including a but excluding b, including a but excluding b. It means we cannot consider this element. Suppose we have 2 less than is equal to x less than 7. So basically this, the representation of this 2, 3, 4, 5, 7, 6, not 7. So these all elements will belong to in this interval. If we take in place of a 2 and in place of b 7. So next A is open, this is open and this is a close. So we can represent this like that x such that A less than x less than is equal to B is an open interval from A to B. This is also an open interval and this is also an open interval including B but excluding A. Here A is not including but B is including. Suppose 2 less than x less than is equal to 7. So we can represent this like that 3, 4, 5, 6 and 7. We cannot include 2 here, we should start from 3 because this symbol shows for the open interval. For open interval talk about we cannot consider the given element in the set or in the representation in the interval. So basically this is a representation, and after that we can understand all these things with the help of example. This diagram represent the open interval. Open interval. This blank circle, this is not colored by black color, and this is also not colored by black color, so that this empty circle represent this is a open interval and we can take all the values between these 2 points, all the values, all the interval between these 2 points which are possible, we can take all the values between these points, but we cannot consider a and b. And after that let us understand another example like that. Another example, this one. Here, this black closed circle represent this value include in the interval, and this also black circle represent this value also include in this interval. So basically this interval is called a closed interval. Closed interval. Okay. And we can represent like that. We have already discussed about closed interval, and representation of the closed interval is this: a less than is equal to x less than is equal to b. Open interval a less than x less than b. This is a representation of a open interval. And after that, we should talk about the next diagram which are given here, this one. You can see in this diagram, this circle not filled by black color, so it means this is for the open. This so for the open interval, open value, so we cannot consider the value of B. But if you see this circle colored with black, maybe you can choose any color in place of black. So it means this is a representation for the closed side. So that's why we are using here close interval sign, and here we are using here open interval sign. So A is included and B is not included. So we can write like that: A less than is equal to X, only less than B. This is a mathematical representation of this set. And after that, we can use the reverse of this diagram, reverse of the previous one. This is a open interval, this is a closed interval. We can represent like that in the braces, and mathematically we can represent A less than X less than is equal to B. B is included and A is not included. So basically, this is a representation for the intervals, and this is also very important. So let us understand all these situations, how can we use in the questions. Here we note that the interval contain infinitely many points. For example, the set this x such that x belong to real number minus 5 less than x less than is equal to 7. Written in the set builder form can be written in the form of interval like that. Basically, this is the representation of this mathematical representation like that in the braces minus 5 minus 5. This bracket represent for the open, it means, and comma this sign for the close interval. Okay, this sign used for the open value, and this less than is equal to this represent for close. Okay, is it clear? This is open bracket and this is close bracket, and same as it is here, this close sign is represent for that x is less than is equal to x, and 5 is for the open interval. We cannot consider the value, so we can also write like that: minus 3 minus 2 minus 1 0 1 2 3 and 4. Basically, this is a set of this representation. Due to this representation, so the value of this representation is this. This will be the set. Okay. So all these explanation basically belongs for the interval. And now the number b minus a is called the length of any of the interval ab. This ab or this ab and this ab. Whatever representation in the braces of the interval, but the length of the interval must be length of interval is equal to b minus a. This is a basically formula to find the length of the interval. Is it clear? B minus a. Suppose the value is given 8 comma 20. So this is A and this is B, but both are in the open interval, so we can put it here 20 minus 8. So length of this interval is equal to 10. Length of this interval is equal to 12. So this is a basically representation of intervals, how can we represent, how can we understand, how can we identify all these symbols, relations which are given in the interval, and how can we represent the interval. Okay, so this is the basically explanation of the interval. Thank you so much.